So there's 3 rules to economic modeling, and the way to really think about economic modeling is that it's a system of logic, and its purpose is really to help you design your own worldview and to think through a problem more deeply. And to do that, you're going to have to follow some rules because a logic requires some rules. So here's the basic 3 rules, and I'm going to go through them one by one to try to explain each. The first rule is that the choice variable has to be as far inside the function or inside the parentheses as possible. So when you're putting together functions, and I'm going to use this classic example that I like, that we're maximizing a student's grades minus their opportunity cost, benefit minus cost, by choosing the time we spend studying as a student. So this is a model from a student's perspective. And to think about this, we notice that this model follows that rule. The time spent studying is as far inside each function as it can be. But what would happen if we, and another way of thinking about that is the time spent studying is chosen by the student to influence their grades. The time spent studying also influences the opportunity cost. So you read models from the inside out. And the big reason you need those choice variables as far inside the parentheses as possible is because when things are inside parentheses, they can influence everything else. And we want our choice to be the central piece that's influencing value and utility and grades and everything like that. So what happens if we violate this? What happens if we build a model like this that violates that rule? Well, this says the student is maximizing the time they spend studying, which is a function of intelligence. Well, that's, when you first read it, it seems okay. But the problem with this is that as soon as I give you intelligence, as soon as I give you a person's IQ, that immediately determines the time they spend studying. And there's no option for this person to actually influence that decision through their own values. Utility can't come in, grades don't come in. So we can't have some exogenous variable that's already determined directly determining our choice. We need to leave that choice up to the person whose decision we're modeling. This rule can actually be very confusing, and the reason for that is it feels kind of okay for the time spent studying to be a function of intelligence, which is the exogenous variable. And the reason that feels okay is because that's actually at the other side of the modeling process. So if we look at this well laid out model that follows rule number 1, where time spent studying is inside the parentheses, if we take the first order conditions, we're going to get the optimal time spent studying, which is different than this S. The difference between these two S's is that this one has a star, meaning this is the specific time spent studying that optimizes the student's utility, where utility is defined up here by grades and opportunity cost. This S has not yet determined what its optimal value is. This is just, this S could take on any value, and we don't know the optimal until we actually solve the model. So at the end of the modeling process, we get our choice variable on the outside of the parentheses as a function of all of our exogenous variables. So time spent studying is going to be a function of intelligence and extracurriculars. So at this point, you can plug in intelligence and extracurriculars and give you the optimal time spent studying, but we don't do that at the beginning of the model because we want the person to have the freedom to make their own decision. All right, so rule number 2, there needs to be a choice variable in every term. And this is probably the most intuitive of the 3 rules. You can't have some random term in there that has nothing to do with your choice variable, because the whole purpose of the modeling process is to model a particular decision. So here we're modeling the student's decision to spend time studying. Now we might want to add a term in there that that is the satisfaction the student gets as a function of the food they eat. And it's true that the amount of food you eat influences your satisfaction, but this has nothing to do with studying, so it really doesn't belong in our model. Even if this is a model of a student's decision, and students might care about satisfaction, this is just irrelevant to what we're actually doing here. So This one's the easiest, that every single term needs to be relevant to the thing we're modeling, and that means it needs to have our relevant choice variable right in the middle of it. All right, rule number 3. There needs to be a force pulling each choice variable in both directions. So basically, another way of putting this rule is that the optimal choice should not be 0 or it should not be infinity. If it is, the decision isn't interesting enough to model. So looking at this, we might start to put together a model that says, let's maximize our grades by choosing the time we spend studying. Well, if you look at this, there is a very obvious optimal choice for us, and that's infinity. You want grades to be as high as possible, 4.3, 5 point whatever, if that's possible. So you just spend as much time as you can studying. But we know that's not really what happens. Students don't spend all their time studying. There is some force that causes their time spent studying to be lower than infinity or lower than 24 hours a day. And what is that force? Well, that's what we need to figure out to complete our model. So models need to have forces pulling our choice variable in both directions, and the whole point of the model really is that analysis associated with identifying the two different forces that pull your choice in both directions and thinking about the struggle that a decision maker has to go through when they make that choice.